Good afternoon, good evening, and good morning somewhere in the world. This is the 11th Bitcoin Cash Developers Meeting of 2019, and we are going to do the usual introductions in a minute, and then I'll go over all the details of what we'll be discussing today. So I'd like to start the introductions with my top left is Antony Zegers.
Yeah, I'm Antony Zegers, Hungarian. I do various Bitcoin Cash related stuff, mostly helping out with ABC and other stuff. Yeah, that's all.
Thanks, Antony. Next I have is Josh.
Hey, I'm Josh Ellithorpe. I work on a lot of miscellaneous BCH pieces, including like Cash Shuffle, BCHD. Happy to be here.
Thanks, Josh. Next is Amaury.
Hello.
Come on.
Well, I'm Amaury. I'm a lead dev for BitcoinABC.
Oh, thank you so much. All right, and Jason B. Cox.
I am Jason Cox, a software engineer contributing to BitcoinABC.
Thank you. Fernando. And
Hello, my name is Fernando Pelliccioni. I am the maintainer of Bitprim node.
Bitprim node, thank you very much. Mark Lundeberg.
Hi, I'm Mark Lundeberg. I'm a Bitcoin Cash developer working on also various projects, trying to get the Schnorr signatures working well, and yeah, lately also focusing a little bit on ABC development.
Great. From the other side of the world, Chris Pacia.
Yeah, how you doing? I'm Chris. I work on primarily the BCHD implementation.
Thank you, Chris. And then on my far right, I have Andrea Suisani.
Hi everybody, I'm Andrea Suisani, Sechet, BU developer.
Thank you. We are expecting one more person to come in, but we're going to start where we are right now. And that would be with a status update on the various node implementations and any notable updates since the last meeting. So we'll start this off with BitcoinABC. Who would like to take it?
Well, there's nothing notable new.
Nothing notable? Okay. Jason, do you have anything to add to nothing notable?
No.
Okay. Antony, anything new?
Well, no, not really. I guess we just did a release yesterday or the day before, so that's just the regular on the regular schedule.
Okay. All right, that's great. Thank you. Any questions for anybody at ABC? No? All right, we'll move right on to BCHD. Which one of you two guys would like to take it?
Well, I can go ahead. It's so we had another release last week, I think, 4.16. So there was some incompatibility that Mark actually found in the num to bin opcode that it hadn't caused like a chain fork yet, but there was an incompatibility there that we addressed. I also I kind of refactored some things, and I imported the full set of test vectors for the script from ABC. And so now, so we had some test vectors in there that were from when I forked BTCD, which were still test vectors, I guess, from in earlier versions of Core, but not really the full set of test vectors since the BCH fork. So I imported that whole thing. Actually came up with two other bugs in the multi-sig opcode in the course of doing it. But now it completely passes that test vector file, the JSON file from ABC, which is good. So hopefully that's the last time BCHD will unintentionally fork itself off the network, but we'll see. So other than that, there's some interest on the part of the Electron Cash developers on maybe switching the backend to using BCHD, and so they've been in touch with like a couple of API calls that they need just to make it work, Electrum work. which I haven't got back to him yet. I don't fully understand the use cases for that, but it's possible that BCHD could be used as a backend for that sometime soon. We'll see.
Great, thank you, Chris. Josh, do you want to add to that at all?
I think Chris covered it.
Okay, cool. Andrea Suisani, Bitcoin Unlimited.
Nothing mentioned to report.
Okay. Move on to Bitprim, Fernando.
Well, I am working in some internal stuff, like continuous integration improvements and something like that. Nothing important.
Okay. Thank you for that update. And then the last one on my list is BCash. We don't have anyone here from BCash. Is there anything anybody would like to report about that? Nope. Then we're going to move on to item number 2 on the agenda, which is a discussion of potential items for the next upgrade. So the first item we have is the draft specification pull request. And I have Antony beside that. Do you want to speak to that, Antony?
Sure. Yeah, I was just going to mention to everyone that I created a pull request for the specification for the next upgrade. Basically, just to get something to like have a common thing that everyone can look at and comment on and stuff. So I was thinking of merging it in pretty soon. If people agree with that, it would obviously say like draft, and you know it's not a final spec or anything like that, anything close to that. But I guess I just wanted to see if anyone has any objection to me doing that, and just let people know that maybe have a look at that and give some feedback or comments. Still, like obviously in flux and depending on what we do. Any feedback or?
Mark, did you have something?
Yeah, I think it's good to get started on that. I liked last time that we had that draft upgrade proposal merged in early on, even though it changed a lot later on. It was still pretty good.
Yeah, I just look at it as a working document, so that's great.
Yeah, that's basically a working document. I'm just like, okay, well, I don't hear any objections, so I'll go ahead and do that.
Anthony, is the one that you opened like 20 days ago or something?
Yeah.
Like, yeah, okay. So
yes,
I already read it. It's okay.
Yeah. Basically the main, yeah, like it's just linking to the work in progress.
Okay.
So if there's more stuff to add in or remove or change, then that can just be done as necessary.
Yeah, I think it's good to get it landed, because then people can open different pull requests to discuss particulars of different topics.
Yeah. Yeah, that's what I had in mind.
Okay, good. No further comment on that. We'll move on to the next item, which is Schnorr for CHECKMULTISIG, and I guess that would be Mark, you.
Yeah, so I guess trying to remember what we talked about in the last meeting, but I think we're getting pretty close to a firm spec. So yeah, once Antony posts once merges that the general upgrade plan into the BitcoinCash.org repository, I can open a pull request and post the full thing there. I've already gotten lots of feedback, so yeah, I'm hopeful that this will be generally seen as good and ready for the next upgrade. Yeah.
That's awesome, Mark.
Any other comments for Mark or questions? You guys have ultimate clarity today, which is great. Move on to the next item, which is BIP 62 items, null dummy and minimal data. Who wants to carry this one?
I can talk about that one again. So I've been looking a lot into this one as well. I've sort of been trying to push hard to fix this last malleability vector, which is the ability to change script sig push forms. And so I think last meeting I was talking about how I'd prefer just the simplest rule possible. But I've been talking with various people, and it sounds like everyone's pretty much okay with activating the minimal data rule, which is significantly more complicated, but it's been a standardness rule for years now. So I've talked to people who are doing complicated things in script. They don't seem to mind these more complex minimal data rules. So there's push restrictions, not just for the script sig, it's for the script pub key, for the redeem script as well. There's also number encoding restrictions in there as well. Yeah, so I've actually written up a full spec now, and I can also post that to the bitcoincash.org repo soon. And I think spec is a good idea because it's not trivial what's exactly happening with this minimal data rule. So just make sure everyone's on the same page with the consensus rules if it does become consensus. Yeah. If anyone has any questions.
And a question for you regarding the null dummy. You said you were considering dropping it for, I think it was the Schnorr multisig, right? So using that bit field for something else.
Yeah, so I don't know if we talked about this last time, but with the new Schnorr multisig, we were looking at various different options. It's a very complicated opcode, so there's a million different ways you can do this. It's much more of an engineering challenge than just bringing in Schnorr signatures in the first place, I would say. But I think we've got a good solution now, and that's just we'll repurpose the dummy element, which should be null right now, but that's not a consensus rule. We'll be repurposing it as a bit field, which indicates which signatures go with which public keys. So this is actually nice because it keeps the same number of stack elements being removed from the stack when you execute the opcode. And that's nice for people doing really fancy smart contracts and whatnot. And also, yeah, it's sort of like something we get for free. It's just there. We can finally make use of this dummy element, which is, until now, it's just been a sort of a wart in the protocol. So
would that be for ECDSA signatures too, or just Schnorr?
Just for Schnorr, yeah. The idea is the ECDSA working as is, like completely backwards compatible, because wallets do rely on that. They just push the null dummy element. So yeah. And the reason to not admit ECDSA signatures into the new mode with the dummy element being non-zero is you don't want people to be able to convert from the null element to a non-null element, which is another malleability vector. So the new mode would be just Schnorr, basically.
Any further comments?
So that would take care of the malleability vector there? Sorry if I'm breaking up.
Yeah, so that actually takes care of the null dummy malleability vector, because now in the ECDSA mode, you have to use null. Otherwise, if it's not null, then it will trigger the Schnorr mode. And in the Schnorr mode, it's not malleable either, because you have to exactly specify which signature goes with which public key. The only case it would be malleable is if you had like repeated public key, and like if there was ability to move around signatures to match with different public keys and they were still valid. That's a really rare case, but that would still be malleable in that case. I don't think anybody really does that though.
Yeah.
Sorry, go ahead.
Oh, go ahead. I was just gonna say I'm just trying to think of whether that would be malleable under current rules anyway, but maybe you could construct something.
There's cases like that under current rules. Like if we were to just turn on the dummy element rule, if people repeated public keys and there was only, it depends how you order them.
Yeah. But you could like change, like if you had multiple public keys that are repeated, you could just change the order of signatures or whatever. Yeah. My question was allowing non-null. So basically, like from the old rules, it'll now look like you're allowing a non-null dummy element. How would that affect like the network propagation and stuff of transactions? I guess everyone would have to upgrade to the new version anyway, because now it's like a non-standard thing.
Oh yeah. Yeah. So I guess what will happen is, right now null dummy is standard, but once the upgrade activates, then null dummy will become irrelevant because it will be overridden by this new mode interpretation new mode mechanism that triggers for non-null element. So.
No, I did want to clarify that because you said it would still be null for ECDSA, the ECDSA mode. Is that going to have to be called out in the spec? I know it's kind of implied, but it sounds like it's still going to be enforced.
Oh yeah. Well, it'll be like implicitly enforced, but I guess it's worth noting that, and there'll be test vectors for this, of course. Yeah, like you won't be able to have ECDSA signatures if the dummy element is not null, because then it'll go into this other mode where it only looks at Schnorr signatures. It only verifies.
Oh, I see. So the mode is going to be detected based on that value.
Yes. That seems to be the simplest way to go.
Yeah, that makes sense.
There's properties to it. Yeah. The full spec is out there. Just maybe it's good to open a pull request for that, and we can.
It's actually linked to it from my draft spec, so people can find it that way if they look at that pull request. But I'll merge that in right after the meeting.
Yeah.
Okay.
So.
Thank you, Mark. Any further questions for Mark or discussion on this? Hearing none, we'll move on to the next item on the agenda, which is an update on the ABC transaction index change version 19.7 release. I have Mark, your name beside this one as well. So.
Yeah, I mean, I backported that from Core. So that's something Jim Posen developed on Bitcoin Core a while ago. And yeah, backported that. It seems to be going well. I haven't heard any complaints. So nothing to say really.
Any complaints from anyone in the room here? No, I guess we're all good. Move on to the next item then is the QUIC, or the QUIC Protocol. Is there anything new to report since the last time this was discussed? And I guess this is open for discussion.
No, there's nothing very notable on that front.
Yeah, I haven't seen any development on that front yet.
Okay.
So this might be a little off topic, but I'm kind of curious just the other developers' thoughts. As we're developing, specifically like the new multi-sig support with Schnorr, have we taken a look at common libraries that people are using for multi-sig and audited any libraries that we'd want to add that support to outside of the full node support? And have we gauged the level of effort for us to be able to implement that so that it's easier to use for developers?
I would not expect it to be very difficult, especially the new proposal. So nothing of that is final, right? But the new proposal that Mark has been talking about, the layout on the stack is similar to what we have already. So if the library has access to, you know, some signature generator that generates Schnorr instead of like, so you need to change to generate Schnorr signature instead of a CDSA. That would be one change, and that should be fairly easy in most libraries. For the non-multisig version, this part has not been an issue. The second one is that you need to generate the proper bitfield value, and like essentially that would be the only, you know, the only part that may be challenging. But I mean, like if it's challenging, there is something seriously wrong with the library.
Yeah.
Awesome. I was just curious.
I can say, like, I've looked at Electron Cache in detail about this, and doing multi-sigs properly already is, it's a little bit weird because you have to figure out the right signature order anyways. But like you have to make sure the signatures are in the right order that sort of matches the order of the pub keys. But and this requires like verifying signatures that you get from counterparties so that you know where to insert your signature, for example. So it shouldn't be too hard to adapt. The existing complications of multi-sig should be like, it should be a framework where you can add this new thing into easily enough. even to generate the bit field, as Amaury was pointing out. Yeah.
That's great. And then one other quick question, since we have a little bit of time, is are there any features being worked on the node that are not consensus level features that we would like to discuss or that are actively being worked on that we should provide a status update on?
Well, if you want to go that road, there's some work that I've made on the QUIC front, but nothing, like nothing very relevant yet, but it's going to end up in the network layer. So it's going to eventually affect other nodes in the network. So what I've been doing, actually, there is a QUIC implementation that have been released by Facebook during the F8 event, maybe a month or two ago. And so I've got in touch with those guys and I've been sending patches to them so that we can decouple what they've made from TLS so we can use whatever we want as encryption layer. And once we have that, we can use that library to do whatever we want.
Is there an easy place for us to see those patches that you're providing? It just would be really useful to the BCHD team to see exactly what you're doing on the C libraries so that we can start some work on the Go implementation.
Yes and no. So things that have been done already are visible. Like if you go see the QUIC library from Facebook, you're gonna see the patches in and all of that. But it's not quite clear what the API is gonna look like at this point. I'm still talking with those guys to know. So there is a good chunk of it that is very much in flux because we don't really know what it's gonna look like. The goal that we have right now is very much define this API, so right now like all the usage of QUIC that they have is using TLS, and so there is no really well-defined abstraction boundary between TLS and the rest of that QUIC implementation. Right, so this is what we're working on. So this is mostly refactoring, and the way we're going at it is that we look what is the TLS specific stuff that is the most pervasive in the code base. Well, this is whatever component. Okay, well let's build an abstraction for that component and migrate the code base to use that abstraction, and then we move to the next one. So
this would be with the idea of replacing TLS with noise. Am I right?
Yes.
Okay. So would the rest of the protocol developed by Facebook there be compatible with the rest of the spec for QUIC minus the TLS, or would there be other changes?
It's compatible with the IETF version of QUIC. So for people that are not quite aware, QUIC has been developed initially by Google. They released it in the Chrome browser and they support it in most of their server application. You can connect using QUIC. And they iterated very quickly, and now it's in the process of being officialized by the IETF. And there are a few differences. Between the original QUIC from Google and the IETF QUIC. So the one that we would use would be the IETF QUIC. But any library that support QUIC IETF should be compatible. And if it's not, this is a bug in one of the two libraries that we need to report.
Okay, cool.
Whoever is maintaining those.
Cool.
Any further discussion?
I do have one more thing to bring up, actually. I was talking with Tyler Smith, and he had a question about what is the full node support of SPV wallets going to be looking like? Are there any plans for dropping BIP37 in the near future, introducing neutrino support, this kind of thing? So I'm just curious. I know I'm on ABC, I'm trying to help out with bringing the BIP157 support in. I don't know when that's going to happen, but I'm curious about the other nodes. Like, I guess BCHD, you've got the neutrino support in already, so that's great. But for example, BU.
So when it comes to BIP37, I think that Core removed it recently.
Yeah, as
Yeah,
I understand,
if I'm not mistaken.
they disabled the BIP37 on by default, like the client's on by default.
Yeah, they still have it. It's just disabled by default.
Okay, so, well, depending on what they do, it's gonna change what we do. Because if they stop supporting it, it's gonna become very difficult for us to support it, considering, you know, just how big we are as an organization, right? It's like a pure manpower problem. So if they decide to go the road of removing it and we cannot have people dedicated to it, then it's going to be very difficult for us to support. As long as they keep it, then, you know, we can just ride on that.
Yeah. And just for the audience, BIP37 is like it was sort of the go-to full node SPV client support, but it turns out that this is not really used by the majority of wallets. Most wallets use something like what Electrum does. They just have an address index you just query, and BIP37 is a more complicated protocol.
And I think in a prior discussion, you had mentioned some wallets that were using it, but there weren't very many that were, I guess, very popular these days. They're primarily deprecated wallets.
That's what it sounds like, yeah. I don't know the full landscape there, but yeah. I heard something
So,
about,
I mean,
Chris?
we do have an SPV wallet implementation, but it's not the default in OpenBazaar anymore. And I'm not aware of anyone actually using it. So, yeah, so apologies if I'm breaking up. I got bad internet. But the in BCHD, we probably will keep it. I mean, we could turn it off by default, but at least a lot of the code that for the SPV stuff would probably also be available by our gRPC API. So I would keep it around for that reason. Right now, when you ask for like a SPV proof, it basically uses the same code. It loads a block, calculates the proof from the block. I assume that's what Electrum X does, right? Or do you know, does it maintain an index of these SPV proofs? I doubt it does that, right?
No, it does. It does query the RPC of the full node for getting the SPV proofs, but it doesn't use the BIP37.
Okay.
Like
right.
Bloom filters stuff. Yeah. But as you say, I think there's some overlap. I was looking at ABC as well. There's definitely overlap there, like getting the partial Merkle roots proof stuff for multiple transactions and whatnot.
Yeah.
But I think that's still useful. Yeah.
Any further topics to be discussed? Hearing none, I'd like to thank you all for your attendance today and look forward to meeting again probably in about another 2 weeks. So we'll go from there. But thank you very much.
Thanks again for
You guys.
Bye-bye.
Bye-bye.